Hey everybody, today we're going to be talking about using arrays in programs. So let's say for instance you're writing a program and that program requires you to have a lot of variables, like let's say 20 to 100 or so or something like that. Now you could actually make them like this. Int number 1 is equal to 0, int number 2 equal to 0, and so on and so forth. Like let's say for instance you have to make a program that asks for 20 numbers from the user and then repeats them back or something like that. Now the problem is that because you need to remember what those 20 numbers are, you can't just like store them in the same variable. So what we are going to have to do is you're going to have to make 20 variables, and then when you repeat them back, you're going to have to repeat back all 20 variables again. And so you can see using like a ton of variables like this is just really unwieldy and really difficult, right? So, well, not really difficult, just monotonous. All right, so what we use instead is something called an array. And an array is basically a whole list of integers, okay, or a list of variables, right? So imagine, let's take a look over here. Okay, so here's your RAM, and in your code you say something like this: int x equals 5. Okay, so what actually happens in the computer is that you get a variable called x, and then in the RAM you get a 5 at that memory location. Okay, but instead what we can do is we can actually say we want to reserve a section of this array or a section of the RAM to use to put an array in. And what that does is gives us a chance to create a whole ton of variables all at once. Right, so the way it looks is like this: int, right? You can just ignore the, it's going to bother me here. Int, okay, autocorrect's going to kill me here. Okay, so what we're going to do is say numbers is equal to new int, and then let's say 10, something like that. All right, so what happens here is in our table, the computer makes a numbers variable, but instead of registering one RAM address, or however large it needs to be, what it does is it registers 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so it goes 10 addresses. And so this section here, I'll just change the color to demonstrate it. Let's go purple. Okay, this section here is the numbers list, okay, the array. Right, let's take a look at how that looks like in our code. Okay, so we're going to say int. Now we're using the square braces to show that this is going to be a list. We're going to give it a name, just like any other variable. It follows the naming conventions of variables. Numbers is equal to new int. And let's say, I don't know, let's just make 10 for now. All right, so we have a list of size 10. Now we've actually created 10 integers. So how do you access them? Well, let's take a look at what this is. Okay, so what happens if I just print out numbers? Okay, let's take a look. So we'll run this. Okay, and you can see here it says I at 15db9742. The I, okay, so this square brace means it's a list. The I is for integers at 15db9742, and that is the memory address where it's located. So that's basically telling you there's a list in the RAM at that location. Let's say I change this to a float. All right, and we run it again. And you can see now it says F, right? The F meaning floats. All right, so I'm going to go back to integers. You can actually make arrays of pretty much anything. You can even make arrays of arrays, which is something we'll get into later. Okay, so if we access the numbers, what we're getting is just a reference to memory. So how do you access individual memory, individual items? Okay, so what we do is we can look over here. Okay, so we can say that the purple section is the array. Okay, but each one of these are called elements. All right, now imagine if you had, let's say, a friend, and a friend, well, I hope you have a friend. Okay, but imagine you have a friend, a whole bunch of friends, 10 friends, and they all live on the same street. right? Now, is it possible, if you only know the first person's address, to give directions to all the other houses? Okay, so that's kind of what we have here. We have this numbers one, and we know numbers is located here. But can we give directions to all the other houses? Well, yes, we can, because if they're all contiguous, now contiguous means one after the other. All right, so if they're all contiguous, it means that we can tell people to go to this location and then move down a certain number of steps, right? And so each one of these gets an address indicating the number of steps that you would take. So this would be address 1, right? Because you go to numbers and then you go down one spot and then you get to address 1, all right? So this would be 2, this would be 3, and so on and so forth. All right, so 4, this is going to bother me. 5, 6, 7, 8, and 9. Now, why is the last, now, are we sure we have 10 items? Let's number them. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, we definitely have 10 items in the array. So why is it that the last one is actually element 9? Well, it's because the first one is element 0. All right, and it makes sense because it means that we go to this address and we move down 0 steps. All right, so what these are called are the indexes. All right, and each one of these spots is referred to an element. So the first element is located at index 0. Second element is index 1, and if the array is size n, the last element is at size n minus 1. All right, so it's always one less than the element that you're looking at, or than the size. Okay, so how do we use that? Well, earlier we looked at something called the for loop. All right, now typically for loops are written like this: int x equals 0, x less than, let's say 10, x plus plus. All right, now a lot of people ask the question, well, why don't we start at 1? Say x is less than or equal to 10, and then just go from there. Like, why do we start counting at 0? Because it's kind of weird. Well, the reason why is because of arrays. If we have size 10, a size 10 array, the addresses go from 0 to 9. But if we wrote our for loops like this, then they wouldn't match up. They wouldn't be able to cycle through the addresses. And this is why we use for loops a lot. All right, so we go 0, less than 10, and that way we can actually use a for loop to cycle through each one of the indexes. All right, and so what we can do is we can say system.println, and we're going to say numbers at x. Right, now what this is going to do is just give us a string of all zeros. Right, so let's try this. Okay, so 0, 0, 0, 0, 0, 0, right? And the reason why is because we haven't initialized any part of the array, and so it's just all zeros right now. Okay, just a good practice I found. Good practice is to use a size variable. All right, especially for beginners. All right, so what I would say is you should do something like this: int constant int size. Now we don't want this to change, and I'll explain why in just a minute. It's 10. And just do it like this, okay? And the reason why is because very often when we're building programs using arrays, what we're trying to do is handle large amounts of data, like 100,000 items or something like that. But when we're testing, you don't want to test with 100,000 items. So we typically test with smaller arrays, and then we just scale them up to be bigger, right? So the problem is here, like if I write a whole code, I don't want to have to like go through and change this 10 to other things. All right. So what I can do, like I don't want to say, oh, there's a 10, there's a 10, there's a 10, and then go through hundreds of lines of code potentially and just look for all the 10s and see if if they're the right ones and then change them. It just becomes a pain. A better solution, especially for beginners, is is to use this size variable. And I'm programming in a different language there, so it should be just final. Okay, so we're using final, which is a constant here. Okay, so another way we can do this is actually in Java, the arrays know their size, right? So what you can do is use numbers dot and numbers dot length. Right, so an array knows its own size. So in Java, if you want, you can use this property of arrays, and you can just use this all the time. Either way doesn't really matter, and I found most beginners prefer just using size variable, okay, or something like that. Okay, but either way is acceptable. All right, so now that we can do this, we can actually print out each item in the array. Okay, well, how do we assign them? Okay, well, what we do is we can just say something like this. Numbers at x is equal to, and then you can assign it a value. Okay, so in this case, I'll just say rand, again, different language, math.random modulus, I don't know, let's say 100 plus 1. So that'll get a random number between 1 and 100. Okay, and we have it. There we go. All right, now what this does is this for loop just populates the array. All right, what we need to still do is we have to actually display the array. So display the array. All right, and instead of this, we just say what we had before, system.println numbers at x. Okay, and I'm just going to put it like this. There we go. So it just prints it in one row. Okay, and in this one, we got 1, 1, 1, 1, 1. And it's because I'm an idiot. So there we go. There we go. Okay, so we got a random number array. Okay, and it looks good. Okay, so what happens there is we went to our array and we just went item by item, index by index, and in our for loop, we were able to use that for loop, right, to populate the numbers there, and then use the same another for loop, well, basically a copy of it, to go through item by item and search each one and get the value from each one. Okay, that's pretty much it for how you create and use arrays. Now, there's a lot of different things you can do with arrays, and in the next video, what I'm going to do is I'm going to go through some basic operations with arrays. Before I go, I did mention, though, one thing is that you don't want to try and go outside of the boundaries of the array. Now, some programming languages, like C++, will allow you to go outside of the boundaries of the array. So what happens if I access element 10? Well, in Java, you don't really have to worry about it, because what will happen is you'll get an out-of-bounds exception and your program will just crash, right? But, well, I guess that is something still to worry about, but it's actually more dangerous if you don't get the error. And the reason why is because you don't know what's sitting in this RAM here, right, in this RAM memory address. So in other languages, it just lets you access it. And so you can actually start changing the variables in these other RAM locations, and it can be potentially dangerous. So what you have to do is be very careful only to work within the parameters or the boundaries of this array. All right, so I'll show you, for instance, if I say system.println numbers at, I don't know, 100, right? And you'll see I'll get an out-of-bounds exception here. All right, and you can see there, array is out of bounds. Right, that's actually a good thing. Even though you might not think it to get the error, it's actually a good thing that you don't just process and get that. Okay. Anyways, that's it for this video. It's just short and kind of quick here, talking about arrays, how they work and what they are. In the next video, what I will do is I'll go through some basic array functions, like just things that we normally do with arrays, and yeah, we'll go from there. So I look forward to seeing you. Remember to like and subscribe. Thanks for watching, and I'll see you in the next video.